Okay, hi everyone, welcome back to this video series on Cisco ASA firewall. Neighboring solicitation messages. These messages are sent to perform duplicate address detection. By default, the security appliance sends one duplicate address detection message on an IPv6 enabled interface. The security appliance sends neighbor solicitation messages only when it needs to do neighbor discovery. You can change this behavior by specifying a new value under the DAD attempts option. If you specify a value of 0, the security appliance disables duplicate address detection on the interface. If you configure an interface to send out more than one duplicate address detection message, you can also specify the interval at which the neighbor solicitation messages are sent out. Sorry. The security appliance sends out one message every second. You can change this behavior by specifying a new value under the NS interval option. Neighbor reachable time. The neighbor reachable time is the amount of time in milliseconds that a remote IPv6 node is considered reachable. The security appliance can detect the unavailable neighbors in an IPv6 network by using the neighbor reachable time. If you define short reachable times, the security appliance can quickly detect unavailable neighbors. However, it adds bandwidth and processing overhead on the IPv6 enabled devices, and thus configuring short reachable time is not recommended in a typical IPv6 network. You can change this behavior by specifying a new value under the reachable time option. The default value of 0 indicates that the reachable time is sent as undetermined. It is up to the receiving devices to set the It is up to the receiving devices to set and track the reachable time value. Redundant advertisement transmission control. A security appliance can send router advertisements to all nodes multicast address, so the neighboring devices can dynamically learn a default router address. The security appliance includes the router lifetime value to indicate its usefulness as the default router on the network. You can change the router lifetime from its default interval time of 1800 seconds by specifying a new value under the RA lifetime box. Router advertisement messages use ICMP v6 type 1234 and are periodically sent out to all IPv6 enabled interfaces. If you would rather change the router advertisement interval from its default value of 200 seconds to something different, specify a new value in the RA interval box. The transmission interval must be less than or equal to the IPv6 router advertisement lifetime. Lastly, you can configure the security appliance to suppress router advertisement messages so that the security appliance does not provide its IPv6 prefix on an interface such as an untrusted interface. You can do that by enabling the suppress RA option. Example 316 shows the gigabit Ethernet /0. The gigabit 0/0 is set up for the neighbor solicitation messages interval of 2000 seconds, a neighbor reachable time of 10 milliseconds, and a router lifetime value of 1000 milliseconds. The security appliance is set up to suppress router advertisement messages on the interface. Okay, just a second. Setting up the system clock. One of the most important tasks when setting up the security appliance is to verify that the clock settings are accurate. The security appliances can use the system clock to timestamp the syslog messages before sending them as discussed in the enabling log section. The system clock is also checked when the VPN tunnels using PKI are being negotiated to verify the validity of the certificate presented by the VPN peer. The security appliance supports two methods to adjust the system clock: manual clock adjustment, automatic clock adjustment using the network time protocol. Manual clock adjustment, similar to a Cisco iOS router, the security appliance allows the use of the clock set command to adjust the system clock. After setting the clock, the security appliance updates the system BIOS powered by a battery on the motherboard. Consequently, if the security appliance is rebooted, the time setting does not need to be configured or need to be reconfigured. To manually adjust the system clock using ASDM, navigate to Configuration, Device Setup, System Time, Clock, and specify a time zone, date, and current time zones. Cisco ASA supports displaying the system time in the correct time zone. It maintains the system clock in Universal Time Coordinated UTC, but shows it in the configured time zone as shown in figure 316. The configured time zone in Eastern Standard Time EST, which is 5 hours behind UTC time. The security appliance automatically displays the system clock in the correct daylight savings time DST date. Cisco ASDM presents a drop-down calendar where you can select the current date. The calendar year is a 4-digit number ranging between 1993 and 2035. In figure 316, the current date is October 22nd, 2009. Time. Cisco ASDM allows you to specify time in hours, minutes, and seconds using the 24-hour time format. Example 317 shows the clock on the security appliance is updated to use the current time of 11:36:50 and the current date is October 22nd, 2009. The current time zone is CST, where DST starts on the second Sunday in March and ends in the first Sunday in November. Automatic clock adjustment using network time protocol. Cisco ASA provides support for the network time protocol NTP to synchronize the system clock with an NTP server. The device administrator does not need to update the system clock manually because the security appliance overrides the manual clock setting when it synchronizes the time with the NTP server. Setting up an NTP server is important when an organization uses certificates PKI to authenticate users and devices on the network. To set up NTP, navigate to Configuration, Device Setup, System Time, NTP, add and specify the attributes discussed in Table 3.5. Figure 317 illustrates two NTP servers located on the inside interface. The server at 192.168.10.16 is a trusted and preferred server, whereas the server at 192.168.10.15 is the secondary NTP server. Both servers use an authentication key of 919919. They require an MD5 authentication key of Cisco 123 to successfully authenticate the security appliance. Example 318 shows the equivalent configuration of figure 317 via CLI, which CLI is command line interface. To verify whether the system clock is synchronized with the NTP server, use the Show NTP status command as shown in example 319. So here's figure 317, adjusting system clock automatically via NTP. So syntax, NTP arguments and description, syntax description, IP address, specify the actual IP address of the NTP server preferred. If multiple NTP servers are specified, the security appliance chooses the NTP server that is preferred. NTP uses an algorithm to determine which server is the most accurate and synchronizes to that one. If the servers are of similar accuracy, then the preferred server is used. However, if a server is significantly more accurate than the preferred one, the security appliance uses the more accurate one. That is, the security appliance uses a more accurate server over a less accurate server that is preferred. Interface. Specify the name of the interface that sources the packets to the NTP server key number. Specify the authentication key number between 1 and 4294 967295 key value. Specify the actual key of the 35 characters used for MD5 authentication. Trusted key, keyword to specify an authentication key for all the configured NTP servers. Set this key as a trusted key. You must select this box for authentication to work. Authenticate keyword to enable NTP authentication. Configuration management. The security appliance keeps 2 copies of the configuration in the system: the active or running configuration, the saved or startup configuration. Running configuration. The running configuration is the actual configuration that the security appliance loads in its memory. When the security appliance boots up, it copies the saved configuration in its memory and then uses it to function as configured. Use the show running config or write terminal command to display the current configuration that the security appliance is using. These are the most important commands to verify that the security appliance is configured properly. The running configuration is not saved in non-volatile RAM, NVRAM, until the security appliance is instructed to store it there. Example 320 shows the current configuration on an appliance via the CLI. As you can see, the configuration file can be fairly large and complex depending on the number of features configured on the security appliance. The configuration file displays the current version of the system image and then the rest of the configuration parameters. If you prefer to see the same configuration via ASDM, click File, Show Running Configuration in New Window. ASDM launches a new default browser window to show the running configuration. You can see here, output of the show running config. It's quite long. Cisco ASA allows you to specify parts of the configuration by using show running config followed by the name of the command you are interested in checking. As shown in example 321, the show running config ? Command shows all possible keywords you can use, and the show running config interface gigabit Ethernet 0/0 command shows the running configuration of the gigabit Ethernet 0/0 interface. The Cisco ASA operating system enables you to enable and search capabilities when a show command is executed by using grep at the end of the command. Alternatively, include displays the output with the exact phrase matches a show command. You can also use exclude command to exclude lines that match a particular phrase. In example 322, the administrator is only interested in looking at the IP addresses set up on the security appliance and their respective subnet masks in the running configuration. The security appliance can also display the selective output of a show command when the begin option is used. In this case, the security appliance displays the output beginning from a specific keyword, as shown in example 323. The administrator is interested in looking at the running configuration beginning from the physical interfaces using the show run config interface command to do this. So you can see here example 323, output of show running config beginning from the interface configuration. Startup configuration. During the boot process, the security appliance uses the saved configuration as the running configuration. This saved configuration is known as the startup configuration. You can view the startup configuration by using the show startup config or show configuration command, as shown in example 324. As you can see here, the output of the show running config and show startup config may or may not be identical depending on whether the two configurations were synced. Use the copy running config, startup config, or write memory command to copy the active configuration into NVRAM, as shown in example 325. Using ASDM saves the running configuration as startup configuration by clicking File, Save Running Configuration on to Flash. Removing the device configuration. If you use ASDM, you can remove any configured feature by selecting the feature and deleting it or changing the values to their defaults. For example, if you created a sub interface on the gigabit Ethernet 0/0, you can remove that interface by selecting it and then clicking the delete button. Using the CLI, you can remove a configured command from the configuration by using the no form of the command. This undoes the command that was previously entered into the configuration. In example 326, the security appliance is set up for ISA KMP processing on the outside interface. It is being disabled with the no ISA KMP enable outside command. So you can see here, example 326, disabling ISA KMP processing on the outside interface. The security appliance can also remove the current configuration for a specific feature if the clear configure command is used. If the security appliance is set up with an ISA KMP policy 10 for phase 1 IPsec negotiations, the clear configuration ISA KMP command removes all the ISA KMP commands from the running configuration. This is demonstrated in example 327. The preceding example not only cleared the ISA KMP policy, but also removed the crypto ISA KMP enable outside command from the running configuration. Use the clear configure crypto ISA KMP policy command to remove only the ISA KMP policy from the active configuration. Unlike a Cisco iOS router, the Cisco ASA can clear the running configuration without going through the reboot process. This is helpful in a scenario where the security appliance needs to be put into the default configuration. Use the clear configure all command to clear the running configuration, as shown in example 328. With ASDM, you can also clear the entire configuration of a security appliance by clicking File, Device, File Reset Device to the factory default configuration. ASDM prompts you to configure an IP address on the management interface. You can re-establish your ASDM connection to this IP address. The security appliance can also erase the startup configuration from NVRAM if the write erase command is issued from privilege mode, as shown in example 329. So I'm going to leave it here this evening for this video. If you like listening, please consider like, sharing and subscribing. Thank you.